Alright, so today we're going to be talking about writing word or using inequalities to help us solve word problems. Now, the biggest goal with word problems is to be able to turn words into math, and so it's really sometimes quite ambiguous which symbol that they want you to use in order to solve, especially with inequalities. Equals is pretty easy. Whenever they say they want something to be the same or equal to or, you know, things like that, you can pretty much well bet that you're going to be using an equal sign. But with less than, greater than, less than or equal to, greater than or equal to, it's a little bit different, right? There's going to be a whole lot of different words and phrases that imply each of these different symbols. So here I just wanted to make a chart that shows you kind of a few of the different things that you'll see for this type of problem. Alright, so some of the words or phrases that you'll see when you need to use a less than symbol instead of an equal sign is something like is smaller than. Or also is just straight up is less than. And then finally, below. So these are three different phrases that mean the same thing. It implies that you want to use the less than symbol in your problem. Okay, so greater than is kind of the opposite of that. One of them is more than. Is bigger than. And also is larger than. And finally, just the word above. Okay? All of these imply less than or greater than between them. Okay? Less than or equal to, greater than or equal to, there's a few key differences. For less than or equal to, one of the words that implies that one is maximum. It's telling you that there's an upper ceiling, right? There's a highest possible value that this can be. Everything else has to be less than that. The other one is at most. So it means the same thing. Highest possible value can be this. Okay. Another one, not more than. Okay, or is not greater than. Okay, and the other things is that any synonym of this, so any word that means the same thing, like greater, bigger, larger, you can replace here. So is not bigger than, is not larger than, etc. Okay, greater than or equal to is minimum. So it's like a floor value. You can have a lowest value of this, but everything else has to be bigger. Okay, at least. Also is not less than. So that the value cannot go lower than. And finally, not smaller than. And remember, you can replace smaller with any synonym of that word. Not littler than, not etc. Okay, so now we're going to use these to help us set up a word problem and then solve it. Okay, so we're moving on. My first example here, it says Keith has $500 in a savings account at the beginning of the summer. Okay, he wants to have at least, so there's that word, that's one of the words from our chart, right? At least $200 in the account by the end of the summer. Okay, so he withdraws $25 each week for food, clothes, and a movie ticket. Write and solve an inequality that represents Keith's situation. the last question tells me what my variable is, how many weeks. So my variable x is equal to the number of weeks. Okay, so I circle all relevant numbers. I've got $500, $200, and then $25 each week. And I want to go through and just change anything that I can into math. So at least, remember, is in that symbol for greater than or equal to, right? So I can change at least to greater than or equal to. So that's my symbol, right? Now I just have to decide what goes on it. Well, it's about the money he starts with. So he's got $500 in a savings account. So I'm going to use that. And then we have to ask ourselves, what is he doing with that? Well, it says he withdraws. So withdrawals implies subtraction, right? I'm taking away from that total of $500. And it says $25 each implies multiplication, right? It's $25 per week. So I'm going to use, right, 25, and then remember week I can replace with x because that's my variable. Okay, so I get 500 minus 25x, and then I have to kind of go back a little bit because he says it says at least $200, so he doesn't want this side to go below $200. So he wants to save at least $200 by the end of the summer. Okay, so it says 500 minus 25x has to be greater than or equal to 200. Okay, so now I want to solve this for x. Okay, I want to make sure that this x value doesn't take my total below $200. So I'm going to subtract 500. Okay, got to get rid of that first because it's by the x. So we get negative 25x is greater than or equal to negative 300. Okay, and then divide both sides by negative 25. So it's negative 25 times x. Okay, because I'm dividing by a negative, remember what I have to do is flip my sign. So I get x is less than or equal to negative 300 divided by negative 25 is 12. Okay, so, and remember this weeks. So he can withdraw money from his account up to 12 weeks. So he can do 1, 2, 3, 4, 5, 6, 7, or 8, but he can't go above 12. If it goes above 12, he'll lose money. So we want x is less than or equal to 12 weeks. Okay, so this isn't like our typical word problem where we only have one solution. I actually have 12 solutions, 0 through 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of those work. They can all be plugged in for x and be true, right? I won't go below my $200. Okay, so I want you guys to pause the video and try the second one on your own real quick, and then we'll go over it. Okay. So what you should have done was you read the problem. I got yellow cab taxi charges a $1.75 flat rate in addition to 65 cents per mile. Katie has no more than $10 to spend on a ride. Okay, so that no more than, if we look at our chart, kind of matches up with not more than, right? So that implies that we want this to be less than or equal to. So once you have your symbol down, it's just a matter of setting up your inequality. So it says, well, this is how much my ride is going to cost, right? Over on this side, and this is how much Katie has. Okay, so she only has $10, so that makes this side pretty easy. I want my $10 to be greater than whatever it costs to get into this taxi, right? It's open toward the 10, so. Okay, so I've got a $1.75 flat rate. So just stepping into that cab tells me that I'm going to be spending $1.75. Okay. Now, the next thing that I can change into math is in addition to. That's pretty literal, right? Add to that. So $1.75 plus 65 cents per mile. And it says how many miles can Katie go without exceeding her limit. So miles is my variable, x. So every time I see mile, I can change that to x. And remember, per, I can change to multiplication. Okay. So I'm going to write that out, 175 plus 0.65x. And then what you should have done is solved for x. So I'm going to subtract 175 from both sides. You get 0.65x is less than or equal to 825. Okay. And then to solve for x, I need to divide both sides by 0.65. Okay. And when you do that, 825 divided by 0.65, you get 1269. Okay, so that's the number of miles that she can go max. Okay, so x is less than or equal to 12.7 miles. Okay, this is how much she can go without exceeding her limit. Okay, so I want you guys to try the two practice problems on the back. Just set up an inequality and solve it, and we're going to go over those tomorrow in class. Have a good night, everyone.